calc. We're doing 10.4 in pre-calc, which is hyperbolae. So in example 9, we're going to graph the hyperbola, but as a hint, this is the degenerate case. I picked this one intentionally because I want to show you that sometimes what we do every other time doesn't work because the equation is set up to be not a typical situation, and so we have to adjust on the fly. So I wanted to show you a degenerate case problem so that you would understand that they do happen and that it's not you, it's just the way it works. All right, so we're going to go ahead and complete the square, right? So I'm going to separate my x stuff and my y stuff. So I'm going to have an x squared plus a 2x, right, and leave some space, and a minus 9y squared minus 54y. I'm going to add the 80 to the other side, okay? So cool. So what ends up happening now is I'm going to do my, pull out the leading coefficient, but for the x, that's just a 1. So I get x squared plus 2x, leave a blank space. I'm going to pull out the leading coefficient of the y stuff, and I'll pull out that negative 9, which ends up giving me a y squared plus 6y, and I'll leave a blank space. And on the other side, I have that plus 80, right? We've done a fair amount of completing the square in this chapter. I do my triangle step by dividing this by 2 and getting a plus 1 and then squaring it. So what I did here is I added a 1 on the left-hand side of my equation, so I'll add a 1 on the right-hand side. I'll do that triangle step here, right, and I'll get a plus 3 because I divide by 2 and then square it, so I add 9. But what that is a negative 9 times a positive 9, meaning I just subtracted 81, so I'll subtract 81 from the other side. Well, then suddenly a thing happens. So this is going to factor into an x plus 1 quantity squared minus a 9 times a y plus 3 quantity squared equals a 0. And this is a problem because usually our next step is that we would divide by what's on this side to get a 1 here. But I can't divide by 0. So what's going to happen is I'm actually going to end up with a situation where this is not a hyperbola. This is a degenerate hyperbola. Essentially, it is two intersecting lines. So what I'm going to do instead is I'm going to solve for y. So what's going to happen is I have two options. So I'm going to go ahead and add that 9. I'm going to add this guy over, but then I really like my y's on the left-hand side. So I'm going to go ahead and make this a 9y cubed, or sorry, y plus 3 quantity squared equals an x plus 1 quantity squared, right? So I'll go ahead and divide by the 9, because I'm going to solve for y, so y plus 3 quantity squared equals 1/9 of an x plus 1 quantity squared, right? And then to solve for y, I'm going to have to take a square root, right? So when I square root this, I need to remember to write a plus or minus. So I'm going to get plus or minus the square root of 1/9, which is easy, and the square root of this x plus 1 quantity squared, right? Which is going to give me an x plus 1, right? So what's going to end up happening is I'm going to get essentially two equations. I'm going to get y plus 3 equals 1/3 times x plus 1, and I'm going to get y plus 3 equals negative 1/3 times x plus 1. So really, these are two intersecting lines, right? These are two lines. They intersect at the point -1, -3, right? So they intersect at -1, -3, and they have slopes of 1/3 and -1/3. So basically, these are just the asymptotes, no hyperbola. So I can graph them, and that's just fine, but it's not going to be a hyperbola, right? When I go to graph this, what's going to end up happening is this thing, because of that whole not being able to divide by 0, let's see, -1, -3, right? 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, that's 5, 1, 2, 3, 4. Okay, great. Okay, so from here, one of these lines, so this line has a positive slope, so I'm going to go up 1, right 1, 2, 3. So this line is going to look like that. I know I didn't do a great job, but this is y plus 3 equals 1/3 x plus 1 in parentheses, right? And then from that same spot, that same center, I'm going to have one that goes down 1, right 3. So I have the other line. So really what's happening here is the entire graph is the asymptotes, because this is y plus 3 equals -1/3 times the quantity x plus 1. So it's just two lines. So I wanted to show you because, again, I don't think it doesn't happen often. Most of the problems that we design, especially problems that I put on the test, are not degenerate, but when something like that does happen, the first thing you should do if you see that you have a problem like this is stop and double check your math. There's a chance you're wrong, right? We've all added wrong, we've all multiplied wrong, that's possible. But if you have double checked your math and it's still coming out like this, then hey, legit, it's probably a situation like this where we have a degenerate conic.